Hello, and welcome to episode 9 of Penrose From Scratch. And this one's going to be a little bit different. Rather than adding anything particularly to our window manager, we're going to have a look at those kind of pure state data structures that I've been talking about the whole time through, and kind of how they work. Because if you've got a good idea for what's going on with that, then you'll have a much better feel for what you can do with Penrose, kind of how the state is working, kind of what the kind of internal model is for everything. So this is going to be our starting point. This is a very, very useful page in the docs. This is where most of the kind of state manipulation methods live, and the kind of things that you'd want to do if you're thinking about like managing your windows of focusing another client, changing what workspace is active, focusing a different screen, swapping things around, adding and removing clients, kind of querying bits of the state, all that kind of stuff. It's all kind of drills down to this kind of stack set structure. Now, the window manager itself is kind of where that lives in terms of how you get at it. So I suppose we'll quickly have a look at that, and then we'll kind of explain what that stack set is, because if you have a look at the docs, it just says private fields. So you're not really able to directly grab anything off the stack set. There's a lot of kind of invariance about how this stuff works, and kind of assumptions that need to be made inside of Penrose around how this stuff is set up. So if you go in completely mess with stuff, you can probably cause some weird things to happen. So I don't give you access to go and mess around with the stuff directly. You've got all these different kind of methods and accessors for doing stuff. But if you have a look at the window manager, that's got some private fields as well. But the main thing it's got that you kind of care about for how your window manager is this state. And this has got two main things that you can get at. The config, which is the stuff that you build and pass in. So that's all your kind of border colors and default layouts and workspace names and floating classes and hooks and all that kind of stuff. And then there's this thing called a client set. And a client set is just a stack set that isn't generic anymore. So stack set itself is generic over what you can put inside of it. You'll see why in a bit. It's largely because the things inside of it are generic. So stacks can hold multiple different things, and it's kind of leaving things open for kind of storing richer information. So at the moment we just store window IDs. We could store a bunch of information about each window and kind of try and keep that up to date. So the data structure supports that, but at the moment a client set is just a stack set that holds onto X IDs. So you've got that client set, you've got your config, and then there's also the kind of extensions stuff we've looked at in a previous episode in there as well. This client set is then, when I'm talking about the pure state, this is the pure state, the stack set, or the client set, depending on which way we're going to talk about it. There's a lot of stuff in here. So if you go to view source, you'll see that there are a bunch of things that are accessible inside of the main Penrose crate itself, but they're not accessible in client code. In client code, client code, that's the wrong way to talk about this. They're not accessible to you as a user of the library. I'm too used to talking about like server client stuff from work. What we're going to do today is we're going to have a look at what all these things are. Now, these bits here, these three, previous tag, invisible tags, and killed clients, are kind of bookkeeping kind of things that we hang on to for doing some kind of stuff around the refresh and kind of tracking certain responses we need to have to events coming through from the X server. The kind of bits that we really care about are these three up here. So the screens, hidden workspaces, and floating window positions. So we'll have a look at how all that stuff works. And then we'll have a little bit of a tour of, once we've done through that, we should be able to have a look at some of these methods and see kind of what they are doing under the hood in reference to how this data structure works. So the whole thing is kind of a big tree. And so to help kind of have a look at this, I'm going to build up a little diagram using something called GraphViz, which is quite nice. It's just a little kind of language you can use for specifying graphs. So it's kind of fun. And I've got this set up so that as I edit the graph, this will show up here. So if we say stack set as our kind of starting point, it says stack set. And hopefully that's big enough to see. We shall see. So first things first, what's in a stack set? Well, we saw that from the source. The things we care about are the screens, hidden workspaces, and floating window positions. We'll kind of cover the floating window positions last, I think. So the kind of two main things that we kind of care about are screens, floating, and hidden. I'm just going to say WS. There's going to be a lot of stuff in this diagram, so I'm going to kind of try and abbreviate stuff where I can. And I might need to drop that font size down a bit as we build up, but we'll see. Okay, so that's kind of the top level stuff that's inside of a stack set. There's the information about the screens, there's floating window positions, and there's workspaces that are currently hidden. Now, what's on a screen is a couple of things. So a screen, if you have a look here, is one of these stack things. And so this is a pattern you're going to see all over the place inside of Penrose. So that has up, let's say that screen 2 has focus at the moment, because that's what I've got just now. So why not? And we've got down. So what is going on is you can kind of think of a stack like a linked list or a vec, or pick your kind of just linear collection of things. Under the hood, Penrose uses vecdex so that you can kind of mess around with both ends of the vec sort of fairly simply. But kind of conceptually, what you're thinking of is a collection of items where you care about which thing is focused as well as the order they're in. So if you just had a list or like a vector of stuff, it would be something like that. So you'd have 1, 2, 3, 4, 5. That's fine. You could reorder them. So we could also say that we had 5, 1, 2, 3, 4. We could kind of move 5 to the front of it. That's fine. That's an ordering for them, but we also, if you think about what we're doing with our window manager and that red border there, we're also focusing a window, and focusing a window is separate from the order the windows are in. So I can move focus from the left window to the right window, but I'm not actually swapping the windows around. It's not that the thing that I'm focusing is always on the left. So we also need to separately track which thing we're currently focused on. So for example, here we could say we're focusing 2, put a little marker around 2, and then we could still be focusing 2 over here, even though it's not at the same index anymore. Here it's the second element in the list, and here it's the third element in the list. So that's what a stack is getting you. It's this idea of the thing you're focusing on, things that come before it, and things that come after it. It's kind of the idea. But doing that as the data structure means that the thing you are currently focusing on, you always have direct access to. You're not storing kind of a list of 5 elements and saying index equals 1, because it's the second element, and here index equals 2. We're not doing that. We're not sort of storing, here's a vec of things, and I'm also tracking the index, because that leads to a couple of problems. So first problem is, what index do you store if there's nothing there? Because that's going to be out of bounds, no matter what you put. If you say it's index 0, the first element, it's an empty list or an empty array, an empty vec, an empty pick your thing. You can't safely get that index. So you could store an optional index, but then you'd always have to check to see if you had an index, and you should only really have an optional index if the collection is empty. So if you have no index, but you have things in the collection, something's gone wrong. If you didn't store it as an optional index, then you need to always check if the collection is empty. And if it is, you need to kind of completely ignore the index. You shouldn't be touching it. And what happens if you remove things from here? So what happens if I get rid of things so that this is actually only got 2 elements in it? Now index 2 is out of bounds. It's not empty, so we're not saying, okay, it's an empty collection, that's fine, but my index is now too big. What do I move my index to? None of those are kind of impossible problems. You can solve all that, but you end up writing a lot of code that is kind of checking that index is valid, adjusting the index properly, shuffling everything around, all that kind of stuff. And that's what Penrose used to do in the first iteration of this. The stack stuff is much nicer, because the stack stuff, the way this would look for this one is we'd say we have up is 1, the focus is 2, and down is 3, 4, 5. And so we can always get at that focused element. It's kind of sat right there. And if we want to kind of move focus to 3, for example, then we move the current focus to over here. This becomes 3 because we've moved 3 out of here. And so there's some algorithms around kind of shuffling that stuff through and kind of making sure that everything kind of moves up and down as you kind of cycle through elements. But the data structure itself doesn't let you have an index that's invalid, because the thing that is currently focused is a property on the data structure. This also has the nice thing that you can't have an empty stack. So you never have to worry about that case where, what do I do if it's empty and the index is invalid? So what you'll actually see for things when you have these stacks is, if it's possible for that thing to be empty, it's an optional stack. So the screens on a stack set are not optional. You must have at least one screen. But on a workspace, as we'll see later on, the clients in a workspace are also stored in a stack. And when we remove the last client from a workspace, that stack, that optional stack, becomes none. So you can quickly check if a workspace is empty or not, because there either is or isn't a stack on. So there we go. So this kind of stack stuff is used all over the place. And this kind of idea of having a focused element that you care about in the middle of your structure and shuffling through happens a lot as well. And this is something that's called a zipper. So I'll have links in the description and in the repo on what a zipper is. The kind of idea, as far as I can tell, comes from some papers that were written with Haskell. So if you're happy reading Haskell, you can go read through that. If you're not so happy with Haskell, which is fair enough, not many people are, then all you really need to know about a zipper is it's this idea of some kind of collection data structure, but you have the concept of a focused element in addition to whatever other structure you've got. And the data structure keeps track of that focused element so you can work with it. And it actually makes implementing all this stuff way simpler. So, all that aside, but that's kind of useful information because stacks are going to form a big part of this. What comes under a screen? Well, we can go have a look at the docs on screens. Let's go to pure here, because we probably want to keep the stack set one open. So here's a screen. And so a screen has a couple of things. So it has the index that screen is. So is that screen 0, 1, 2, 3, 4? That's separate from the kind of ordering of the screens inside of the stack. That's kind of like the absolute positioning of your screens in your kind of actual kind of layout that you've got for your screens using Xcinerama or whatever else you're using for it. So the kind of leftmost screen, the center screen, the right screen, so on. You've got the workspace, which is another one of these kind of things that knows how to focus stuff. And you've got the screen position, so the rectangle. So let's kind of add that in. So screen 2 has got a rectangle, so let's call that R2. It's got a workspace. We'll say that workspace 1 is on, or what workspace do we have focused? We've got workspace 2, so let's use workspace 2. And we've also got the ID, so ID 1. Oh, sorry, ID 2. And actually, what we'll also do is we'll kind of show a little bit of what's happening with the rest of this. So I've got another monitor at the moment, so S up is also going to have S1 in there. So our screens, our focused screen is screen 2. That's got its rectangle, its kind of position, its X, Y, width and height. It's got a workspace and it's got its ID. And S1 here has got just the same kind of stuff underneath it. It kind of just has all the same stuff that S2 has got, but we're not focusing on that one right now. We're going to leave that alone for just now. Let's pop that there. Right, so in that case, what's inside of a workspace? Well, inside of a workspace, that's where we're going to have some stuff for what's actually being shown on the screen. So as you can kind of see, this kind of tree structure is kind of building out. So the workspace, if my internet will load, here we go, also has a bunch of private fields. And the stuff that we've got in there, again, we've got the ID. So these have all got a specific ID, so they can be kind of uniquely identified. They've got the tag, so that's the kind of name that's showing up down here. And also you can access workspaces by tag. You can kind of search for one by the tag that it's currently got. And then they've got the layout stack, and like I was saying there, an optional stack of clients, which we're going to have a look at. So here we've got ID W. Let's say IDW. We've got tag2, and we've got the layouts, and we've got clients. Like that. Actually, I'm going to put layouts first here, because that just means that when it's making that little image over on the right there, we'll have a bit more space for stuff, and we can kind of see what's going on. Cool. So layouts, let's just cover that one quickly first. That is similar to screens. That's also a stack. So that is going to have an L up. That's going to have, let's say that layout 1 is focused, and it's going to have an L down. And then let's say that L up has got L2 and L3. And let's say that L down has got L4. Oops, like that. Ooh. There we go. So things are getting a bit cramped now. Let's make the font size a little bit smaller. There we go. So yeah, so layouts is another one of these stacks. We can kind of find the focused layout by saying in our stack set for the screens, what screen has focus, what's its workspace, look at its layouts, what layout has focus. That's how we kind of drill down to the layout that's currently active. And for the clients, we've kind of got the same thing. Let's just use up and down for these. So up, let's say that client 1 has got focus, and we've got down. And then up can have C2, and down can have C3 and C4. Why not? What have I done wrong there? Oh, that's not layouts. That should be clients. There we go. Cool. Okie doke. So yeah, so as you can see, like the structure internally for layouts and clients and screens are all the same thing. These are all stacks. So they're all kind of using the same data structure. It's a generic kind of collection type, kind of like a vec, but with this idea of what thing are you focused on. And so for screens, we are focusing one of the screens. For layouts, we're focusing on the layouts. For clients, we're focusing on the clients. But we've also got this idea of what's before it and what's after it. So we've got the ordering. So we've got the kind of where does everything kind of live in terms of that kind of sequence. So first client, second client, third client, fourth client, so on. But we can independently focus one of those clients or one of those layouts or one of those screens. The whole kind of thing is kind of based on these same kind of data structures. Now, I think I can kind of show, if I say, so let's try this. I think there's a way I can kind of highlight this to make this a bit easier. So if I say stack set, screens, S2, W2, clients, and C1 are all going to have style equals filled, I think it is. There we go, cool. We can kind of highlight that path. So if I'm looking for the current focused client, so if we go back to our stack set now, we could kind of say like current client is going to give me optionally a client. That's a method on the stack set to say, hey, I want to work with the current client window, like give me access to the current client window. Well, this is how that method's working. It's saying, okay, for the current screen that's focused and its workspace, If it has clients, give me the focused client. And actually, if you look at the source, I'm pretty sure that's kind of what it looks like when it's implemented as well. You'll see it's just a chain of methods going through that. So yeah, screens, focus, workspace, stack. As ref is basically just saying that I want a reference to that optional stack. And if there is a stack in there, I want the focused element from that stack. So this kind of little drill down of accessors and methods is the same as our tree. If you have a look, it's just I want screens, focus, workspace. If there's a client stack, I want the focused element. Ta-da! That's kind of how it works. If we wanted the layouts, then we'd get down to W2 and we'd say layouts and L1. And that would be drilling down to the current layout. And I don't know if I've got an accessor for directly for the current layout. Maybe I do. I think you can get it if you go to the current workspace. So if I say current workspace, that gets me the active workspace. And on the current workspace, I think there's then... oh, I don't. Oh, I can get the layout name though. But yeah, I don't. Oh, looks like I don't have a way for you to just get at the layout that's active directly. I should add that in. I'll add that in as a method. Why not? But yeah, but you can get, for example, the layout name. So I could get down to that L1 and a layout, like we'd kind of said before. It's one of those trait objects, but we can call methods on it. So we could kind of say L1 layout name. So we can't get to the layout itself at the moment, mainly because the layouts are kind of used internally. You're not really kind of supposed to be calling those yourself. I don't think there's too much harm in letting you have access to that. I'll have a think. I might add that in. But at the moment, you can't go and pop the layout off of a workspace. But there's that layout name you can go get down to. Now, one thing we can do, if you had a look, is once we get down to our workspace, we can say next and previous layout. So I can switch to the next available layout. So how does that work with our tree? Well, we've drilled down to our layouts. So let's not highlight L1 at the moment. So we've gone down through our screen and our workspace, and we've got to our layouts. Now, on our workspace, we've got a method called next and previous layout. So if I said next layout, let's go to that layout name, that's just a bit annoying. If I said next layout, then the next layout after L1 is going to be L4. So what's going to happen is if we call next layout, then our focus is going to become L4. L1 is going to move to up. And L down is going to end up empty because there's nothing left in L down because we've shuffled down to it. Now, if I say next layout again, then what would happen is L4 would move up to here, and we'd need to grab the next thing from L down. There's nothing in L down, so we kind of wrap over and we grab L2. So L2 would end up with focus, and actually L up would end up empty because we've then kind of wrapped all the way around. But in here, we'd end up with L3, L1, and L4. So we'd kind of flip everything over. Hopefully that makes sense. If you have a look at what changed there, we're kind of saying we're on L4 here. We've got everything else is above us. So if I try to go down, I'm going to wrap and end up at the top of up instead. So this kind of the stack is kind of circular. It's like a ring buffer kind of idea. Yeah, we'd end up focusing L2, and L up would end up empty, and this would end up as, what did we have? L3, L1, and L4. And everything kind of goes whoop, and flips over. So that's another benefit of this kind of stuff with cycling the focus with a stack rather than tracking an index, is you don't need to then check, am I at the end and am I going to flip over and sort of end up out of bounds. I suppose internally I am doing those checks, so okay, bad example, but this kind of idea of wrapping round is kind of built in, and you can kind of keep your focus and your ordering separate, which is fun. Let's put that back where L1 had focus, because that was laid out a little bit nicer. There we go, cool. So yeah, we can kind of cycle things through. We can do the same thing with the clients. If we were focusing on the clients, then we can do the same thing. We can kind of say, I want to focus the next client. And that will be a method that's actually up on the stack set itself. So for things that kind of make sense for you to do kind of like just in your normal window manager operation, I don't make you drill all the way down to the kind of individual stack where you want to mess with stuff. The kind of stuff for changing a client, for example, you can get at the current client, you can get at the current screen, current stack, current tag, you can kind of access all those kind of active bits on that path. So anything that's the kind of current one, you can always grab really quickly. And the idea is that you move focus to the thing you want to work with. So you kind of focus the element you want to work with, then you do something with it. And for the most part, with window manager stuff, if you're doing something with it, that's because you want it to be the active thing. So you want to focus the workspace and do something on that workspace, or you want to set and lay out so that it's active and working, or you want to focus a client and do things with that client. So that's why this kind of data structure is optimized for doing things with the element you are currently focused on. It's kind of the kind of main kind of aim of all this kind of stuff. And yeah, it kind of lets you kind of drill down all the way through. And so you should see there is kind of focus down and focus up. So all the methods on the stack set where they just talk about focus specifically are generally about clients. If it's not saying it's focus a tag, for example, or focus a screen. If it's saying focus up, down, head, things like that, then it's about focusing with clients, because that's the main thing you're doing, is kind of moving your focus between windows. There's these rotate methods as well. And so what rotate's doing is kind of shuffling everything along position-wise through the stack. So we can kind of take C2, move it to C1, C1 to C3, C3 to C4, C4 to C2. We can kind of just rotate all the elements through and keep focused on the kind of the same index, if you like. So we are currently focused on the second element in the stack, which happens to be client 1. We can kind of cycle all the clients through their positions so that you stay focused on the second element, but everything else kind of just takes through. Cool, okay. So I suppose the other bit to kind of chat about, we've had a look at what's in screens, which is this kind of big tree structure of how everything works. But if you've been thinking through, you'll kind of see a screen holds onto one workspace. It's not holding on to all the workspaces. So what happens when you're kind of changing the workspace that's active on a screen? Well, that's where this hidden workspaces kind of comes in. So what hidden workspaces actually is just a kind of vec, or kind of a set. You can kind of think of the order is not important in here. I don't use a set because I don't really want to kind of hash everything, but it's a vec where the order doesn't matter. So this has got kind of, what did we get? We had workspace 2. We can assume that workspace 1 is on screen 1, but then let's say we've got W3, W4, and so on. And we end up with the hidden workspaces, like the workspaces that aren't currently focused on a screen, sit over here. So that's got, and each of those will have the same kind of structure underneath them. They will all have an ID and a tag and some layouts and potentially some clients, but they all kind of live off in that hidden workspaces. And if you're saying, I want to focus workspace 4, for example, instead of workspace 2, then all you're really doing is saying on screen 2, I want to swap workspace 4 out with workspace 2. And so screen 2 then gets workspace 4 and everything that's under workspace 4. And workspace 2, the one we've been looking at, gets moved over to that hidden workspaces set. And then all of its state that it's got stays there, it doesn't do anything, but it now lives off in that hidden workspaces, and it's not really accessible to you for doing anything with it at the moment. It kind of sits off to the side. But if you wanted to kind of bring that back, then you just swap it back out with workspace 4, and it pops it onto the active screen. And if you wanted to kind of swap things between the screens, so let's say that S1 had, that's got workspace 1, or sorry, I just said W, didn't I? That's got workspace 1. We could do the same thing there. We could swap that with the workspace that's on screen 2. And so we could put workspace 1 over here, and whatever we've got on workspace 1 is now what's on our active screen. But screen 1, which is the inactive screen, has now got our workspace 2. We've kind of flipped the workspaces on the 2 monitors that we've got. Yeah, and all these kind of things that we're kind of pointing at the moment with doing these, that's how this works internally. We're literally just doing a swap. We're kind of just saying, okay, take the workspace that's on screen 1, swap it with the workspace that's on screen 2. Take the workspace on screen 1 and swap it with one of those hidden workspaces. I want to pull a different workspace onto that screen. But we're just doing these kind of swaps internally within the data structure of all these nodes of this tree. Just by the act of doing that swap then means that when you start drilling down through these kind of stacks that have got the concept of the thing you are focusing on, you end up just drilling down to the data that you need. You don't end up having to kind of index into things or filter through arrays of stuff or hunt around for things or anything like that. It's all just direct property access. So if you think back to what we had with the stuff we had in, where was it? Let's do current client. Let's look at that one. So current client, if we look at the source for current client, like we said before, it really is just, the only method call we've got in here is the kind of asref and map, because we're working with an option, and we need to kind of take a reference to the client rather than remove it from the stack. But this isn't function calls or any kind of logic to go and work out that stuff. It's direct property access through the tree. So it's get the screen stack, give me the focus thing, give me the workspace off of that focus screen, give me its stack. And then at that point, that's an option. So we kind of need to say, okay, well, map over that option and give me a reference to what's inside the focused element that's inside of there, if we have an element inside of it. So I suppose that's kind of it. That's kind of what we're talking about with all this kind of stuff. Hopefully that makes sense. It's a bit of a kind of whistle-stop tour that I've just kind of been through, but the main idea for all this stuff is that the thing that you are currently working with, you just have direct access to immediately. You're not having to run any code to go find stuff. You're not hunting around for things. There's no kind of algorithms or invariants to go and check and potentially mess up. So it actually gets rid of a whole bunch of bugs because it becomes a lot easier to maintain this stuff and to kind of reason about it, because it's just the data structure itself is the invariant. Like a stack can't be empty. It has to have that focused element. And a screen has to have an active workspace at the moment. So you can't end up kind of going, oh, I've lost track of the active workspace. I'm looking at the wrong workspace. Like, it's in the data which workspace is active, which is nice. It's anytime you can kind of push all that stuff down into the data structures rather than like having just everything in like a big array and then hunting through it, much, much nicer. Now, that kind of approach to stuff when you need like massively high performance because you're doing tons and tons of stuff, yeah, agree with that. That's quite important. But for this, where what you're doing is manipulating this tree structure, that's what a window manager is kind of doing, really. Encoding that into the data is really good. It's really nice. It's just a bunch of like nested property accesses the whole way down. The kind of stuff we're doing with this, getting to the element nicely and ensuring that the invariants are correct, massively beats kind of going for some kind of slight speed up in storing everything in a big flat array, for example. Cool. Okay. So yeah, that's kind of this kind of tree structure that we've got for working with. And like I've been saying, this stack set page in the docs and all of the methods in here are a really good thing to have a look at. So if you have a look, there's all stuff that gets kind of lifted up here, which is kind of previous layouts, previous screen, pull tag to screen, remove client, give me the screen for that client, all these kind of things. You can start having a look at these methods and looking at the implementation for all of these. They all kind of work quite nicely and quite simply. Oh, actually, I'm just seeing sync client here, or sync, and I've just realized we've not mentioned how floating clients work, which is probably worth just sort of touching on very briefly just to finish up. It's actually really simple. All floating is a kind of map. So let's say that client 3 down here was floating. All floating is doing is saying C3 has a given x, y, and width and height. Will that work? Yeah. So all floating is doing is basically, it's just a hash map of a client ID to a floating window position that we should have. Or rather, it is, this is something that's called a relative rect. So rather than it be an absolute position on the screen, it's a kind of relative position to the screen that it's placed on. So it's kind of percentages is probably the best way of thinking of it. It's this, like this percent of the screen offset from the top left corner, this percent offsetted down, and it's this kind of percentage dimensions of the screen that it's sat on as well. And that's all kind of got a bit messy. And that's just so that that floating window, as you move it between screens, it kind of takes up the same kind of proportion of the screen when you move it, rather than each time you're kind of working out with that, having to kind of rescale and move the window around explicitly. It's kind of just, it's kind of like a template, if you like. So it's like whichever screen you put it on, it will take up this proportion of the screen. And the way that floating stuff works is when we're laying out a workspace, before this kind of current client stack gets given to the layout for use, we filter out anything that is in the floating map. So we kind of just go through and we say, if there's anything that's floating, we're going to make a copy of the stack for just now. We're going to remove anything that's floating, because we know where that goes. We've got a floating position for it. And anything that's left over, we give to the layout algorithm. The layout algorithm tiles the tiled clients, and then the floating clients kind of go wherever they are. That's why things like opening my Scratchpad doesn't mess with the position of the other windows. Like, it's not like the other windows, the layout thinks it needs to deal with this one. Pardon me. It just, as far as the layout's concerned, there's only 2 clients on the workspace. As far as our data structure is concerned, and our stack set, there's 3 clients on the workspace when I do this. And then when I hide it, I'm actually moving that off to a hidden workspace that's kind of not accessible, that you can't see. So that client just gets kind of popped off of that workspace and added into the focused one. And then when I hit the key binding again, it pops it out of the active workspace and puts it back over on a hidden one. That's kind of it. But yeah, so all that kind of manipulation stuff, you can do whatever you want with the tree. And the modify and refresh kind of logic, that's the point of this diff idea, is this is your tree. You get access to the current tree, change it however you want. Penrose will then diff what you've done to work out where things have changed. So have you changed the active workspace? Have you changed the clients that are on screen? All that kind of stuff. And then that diff is what then drives the rest of the rendering out to the X server. So you can kind of freely mess around with this as much as you want, and you can also make multiple changes. So you can completely change all the workspaces and all the clients in one go, apply that as a diff, and everything will get processed at once. You don't need to iterate through and diff or apply each change one at a time. You can kind of batch them together if you want. But yeah, that's kind of it. Have a look at the docs on the stack set. This is where all these methods are. And hopefully now, if you kind of go and view the source for these methods, this should start making, or not that one, defer to current stack was a macro that's kind of calling methods on the stack. So that's probably a bad example. If I say next layout, is that going to do it? Oh, what's next layout? Oh, there we go. So we say next layout. Yeah, there we go. So it's self.screens.focus.workspace, call next layout on the workspace. So hopefully, if you go and dig into the source for the stack set, you'll start seeing how this stuff works. And this should hopefully make a bit more sense if you have a look at that kind of diagram. I'll leave that diagram in the Penrose From Scratch repo so you can have a look. And it just kind of, it's all just drilling down on those focused elements. And so the thing you always want to do if you're working with something is to just say, focus the thing you want to work with, then work with it. And so you sort of make that kind of tree change first, and then once you focus the thing, you've got direct access to it, you can do whatever you want. Cool. Okay, so now we've been through that. Next episode, what I was wanting to have a look at was implementing something that we did have a kind of version of in Penrose 0.2, but I never ported across, which I just realized the other day, which isn't great. So I should try and port that over. So I think the next episode is going to be me trying to port that across to the new way of doing things. And this is kind of default workspaces, I think is what I'd called it before. I think XMonad calls it like dynamic projects, but it's the idea that if you focus a workspace that is currently empty, and it's the tag that you've kind of specified this for, we set up the workspace automatically. So we set a layout, we spawn a bunch of programs, that kind of thing. So we'll have a look at that, but we needed to have a bit of a look at this kind of stuff because we're going to have to work with the diff, and we're going to have to traverse this tree to kind of work out what's going on in order to run the right logic. So that sounds good. Cool. So stay tuned for that, and I'll hopefully have that for you relatively soon. And until then, happy hacking on your Windows.